In this problem, we have a cancer patient's white blood cell count grows exponentially after she's completed chemotherapy treatments. Initially, that's a good thing to know, she starts out with 63 white blood cells. So right now I know it's an exponential growth, so I'm looking at this formula, y equals c(a) to the x. All right, I know my initial amount is 63. And that's white blood cells. The growth rate, now that's not the growth factor, that's the A that we're looking for, but the growth rate is 17% per day after each treatment was completed. Let C represent the white blood cell count, D represent the days. So we're trying to write an equation with C of D and D instead of X's and Y's. So I can start out with C of D, my output, my count after so many days equals my initial 63, A, now I see the 17%, but remember we don't work with percents, and that's a growth rate. So I need to find a growth factor. 17% is 0.17, that's the extra, but I need to include the initial amount that she started with. So to do that, I add the 1 to that to get 1.17, which is my growth factor. Remember, it's like having the initial amount, that's the 1, and then the extra part coming on is the 17% rate. So the number that goes in here is 1.17. And then the variable D is my input variable. So that's my exponential growth equation. That's all they need right there. Then we're going to use that equation to answer the next few questions. So if this growth rate continues, what would her white blood cell count be after 30 days? So again, the D represents days. I plug in the number 30 into that equation. So the count after 30 days, notice we're not doing anything with the left side of the equation, it's just telling me, giving me information about 30 days later. I plug in the 30 on the other side, and this is the side that we use our calculator for. Round to the nearest hundredth, which means 2 decimal places. So when I do that, I come up with 6,997.07, okay, to 2 decimal places, and then it's white blood cell count. Go back up here to see what the output is. C represents white blood cell count per milliliter, so that's what I'm putting here. For part C, we're still using that same equation, but algebraically determine how many days. So back to my original equation, back up here, I'm now solving for D, so they must be giving me the left-hand side of the equation here. All right, how many days will it take for her white blood cells to triple from her original amount? Well, her original amount was 63, so if I'm going to triple that, times it by 3, come up with 189. That's what I want as an output. So I'm going to put 189 on the left side equals 63 times 1.17 raised to the D power. And now solve for D. So again, we want the exponent or the exponential by itself. So the 63's got to go. It's hooked by multiplication, so I'm going to divide both sides by 63. And guess what number you're going to get? You guessed it, the number 3. Because remember, 63 times 3 was 189. So if I divide, it's going to be 3. You can check it if you want. Now this again is an exponent, So to get rid of an exponent, I need to write the word log down. Log base 1.17 of equals power. My power is D, so what goes inside of here is 3. And then from here, we can use my change of base formula, use either natural log or log, base 10, doesn't matter. Number on top stays on top, base is on the bottom, and then use your calculator to type it in. So again, it's just, let me see if I can get my calculator up here. Yep, I got 2 calculators now. Okay, well, we'll just use one. It was, let me clear that out. Slide it down here. Natural log of 3, close parenthesis, divided by natural log, and then the 1.17. So it says round to the nearest day. So if it's 6.997 and change, we're going to round it to 7 days.